So back in the dark days of the web, doing anything even remotely fun with audio, video, real-time communication, that was the domain of plugins, and we don't really like plugins. This is no longer true. We have a fantastic mix of low and high-level APIs that we can sort of manipulate this stuff, send data between machines, and manipulate audio and video. It's great stuff. To show us how to get the most out of those APIs, I'll introduce our next speakers, Sam Dutton and Jan Linden, everyone.
Thank you. Thank you very much, Jake. I've never been called that before. Yeah, I am Sam Dutton. I'm a developer advocate for Chrome based in London.
And I'm Jan Linden. I'm a product manager on the Chrome Media team with a special focus on audio.
And everyone knows Chris Wilson, who is going to be up performing for us a bit later. So, I can get my clicker to work. There's going to be quite a lot of links in these slides, which might work better online than on the screen here. So if you want to follow along, these slides are up at simple.info/media. So I think we've seen two big changes on the web, and these have happened really suddenly. The first is the stuff that Linus was talking about, the rise of this multi-device web. We've got more mobile phones than like toothbrushes or pencils and so on. There's this commoditization of computing that on a scale we haven't seen since like the PC boom of the 80s and 90s. But the thing is that it's not just kind of the same thing with more computers. The change of devices is actually changing what we're doing on the web. And in particular, like Jake was referring to, we're seeing like the rise of audio and video and real-time communication on the web. And this is, in a sense, I think a lot of it is to do with the fact that we're using these devices now, which are naturally oriented to consuming media and communicating, phones and tablets and so on. This is actually having a knock-on effect elsewhere. I mean, a lot of us, when we watch television now, we do other stuff with mobile devices. We access other media while we're watching television. And in a lot of countries, in fact, TV viewing is down, online viewing is up. I just read, actually, in The Economist about China that, in Beijing, like only 30% of people now use a television. And that's down from like 70% of households, like 3 years ago. Popular online shows in China, they get audiences of like 250 million. And so the predictions are that within a few years, something like maybe 90% of the bits that cross the internet will actually be video. This translates to something like 1 million minutes of video a second. Which is incredible. So, it's not that we're all going to build, the next YouTube or whatever, but we're coming to expect this kind of seamless audio, video, real-time communication in our apps, and we're expecting that on all our devices. So, what have we got? Well, we have these media APIs for the open web, and we have these interoperable, standardized technologies that are working across a huge range of devices. So in the next kind of 25 minutes, we're going to just try and touch on some of the things we can do with those APIs on the web. Perhaps the best place to start, if I don't get any more feedback, is WebRTC. This is perhaps the most ambitious, overused word, but disruptive, really disruptive projects on the web. This is real-time communication built into the browser, open source, plug-in free for end users, free for developers. And this has been like a missing piece of the web platform. And this is kind of crucial for building web apps on devices which are oriented to communication. So maybe the best way to show this in action is let's have a chat. We have, I'm going to use Opera actually on the desktop here to
I'll
go
use
to that address.
Android tablet think
I
that's
can see
better.
someone else has already joined us there. We've got Firefox running over there, yeah, on the Nexus, and then Chrome for Android on the Nexus 7. And you can see that's working pretty well. And this is like a full mesh setup, everyone connected to everyone. So it's not actually particularly, particularly efficient. Hello, Brian. So, this is great. We're seeing great stuff coming through with WebRTC. We've got really great adoption, Firefox, Chrome, and now Opera on desktop and on Android, bindings for Java, Objective-C, and pretty recently, Qt framework started using Chromium, which gives us access to loads of stuff, including WebRTC. So we have well over now 1 billion endpoints, and a lot more predicted for the near future. So the kind of, I guess, the obvious use case for WebRTC is, video chat, like we were just showing. But there've been some really innovative apps coming through. Just back in August, kind of helped out by a company called Vline, Sky did live interview in South London, where I live. And they did that all with WebRTC. In the old days, to do stuff like this, you needed all this kit, all these people, these trucks, all this stuff. And they did it with this really simple setup using like a camera like I've got here and one of these $100 Yeti mics. And I think this is amazing. This is like the democratization, of broadcast. I love this stuff. So, in the old days, real-time communication involved something like this, this highly simplified diagram, but you were required to go through some kind of centralized service. And essentially, that box in the middle was acting like a relay service, which is just inherently inefficient. Perhaps the most radical thing about WebRTC is that its architecture is inherently peer-to-peer. So in other words, wherever you're calling from, so to speak, whether you're on Wi-Fi or on a cell, fixed, whatever, the idea is that you can communicate, be streaming data directly between peers. And this is, of course, far more efficient and better for performance. So what do we need for real-time communication? Well, obviously, we need to be able to get audio and video, from our camera and our mic. And then we need to be able to make a connection between the two peers, the caller and the callee. And that needs to be able to cope with the real world of NATs and firewalls and so on. Once we've made that connection, we need to be able to then have really high performance streaming that works in this modern world of multiple devices. So audio without jittering and video that's smooth and so on and so on and so on. And I guess the other part of WebRTC has also always been this idea that we could communicate arbitrary data as well. So not just audio and video, but all types of data, binary data, text, and so on. And we're seeing some really interesting use cases for that coming through. So for this, we have 3 APIs. Media stream, people may know better as Get User Media. Has anyone here built an app using Get User Media? Oh, that's great. That's like the most I've seen in audience. That's fantastic. And then, of course, we have RTC peer connection and RTC data channel, which I'll talk about a bit. So, on one level, this is kind of a simple concept. You get some media, and then you plumb that into RTC peer connection to get it to the other side. Once you get it to the other side, you've got your media stream, and then you can do something like plug that into a video element. Of course, it's not that simple. RTC peer connection, the bit in the middle, so to speak, needs to cope with the real world, like I say, of NATs and firewalls and so on, and also to be able to do clever stuff to make sure that video and audio work really, really well across a range of devices and a range of contexts.
Yeah, and echo cancellation, all these things that make it for a good experience.
Yeah, there's a stack of stuff that goes on in incredible detail in the design there. RTC peer connection, the whole of WebRTC is also designed with security in mind. So at every stage, everything is encrypted within the code and when you're communicating between peers. which is kind of crucial to this project. So if you want to have a look at WebRTC, check this out. This is kind of the absolute basics. We also have a kind of full-fat video chat app, which is maintained by Google, which kind of does everything and has really verbose logging, so it's a good place to work out what's going on. Think about RTC data channel. Like I say, this is the API for other kinds of data, arbitrary data. Imagine you're playing a game, and it's highly simplified, but you want to exchange player positions, for example, and do that with low latency and kind of effectively, trying for real time. Well, we have, RTC data channel for that, and this has exactly, I don't know who is ringing, but someone. So this has exactly the same API as WebSocket, but what we're aiming for here is really low latency. Firstly, because the idea is that you're communicating directly between peers, and using the SCTP protocol means we have a lot of the advantages of UDP. So what we can do is optionally specify that we don't need the connection to be reliable. In other words, you think if you're exchanging player positions, it doesn't matter if you lose some packets along the way. What you really want is high performance. Whereas, say for file sharing, you can't lose any bits. That's not going to work. So you might take a slight hit on performance to make sure that, that the transport is reliable. So again, if you want to check this out, it's a good place to start. Just wanted to show you a really nice app I've seen using this. I don't know if people have seen ShareFest, but what this gives is the ability to share files using RTC data channel without having to go through an intermediary service. So what I've done is I've selected a file there. ShareFest gives me a URL, and then I can do something like post that URL to someone, and then they can open that file at the other end. So when they come to open that file, a peer connection will be established between the two browsers, so to speak, and then data transfer of the file will happen directly between the two without, like I say, going via an intermediary server. So kind of interesting stuff going on there. Perhaps a more radical project. Have people seen peer CDN? This blows me away. This is this idea of peer-to-peer content distribution using RTC data channels. So the way it works is that you put a link to peer CDN's JavaScript at the top of your web page, and then the way it works is that it will try then to get assets on the page from local peers rather than defaulting to downloading them from the server. So yeah, it's a kind of prototype, but it's this kind of vision for a really different way of doing things on the web. So I kind of skipped over get user media. I just wanted to sort of go into that a little bit more detail. Yeah, get user media is pretty straightforward. You can see here, I mean, you call get user media on the navigator object, and you pass it a constraints object. This is actually really powerful. This is defining what kind of media we want. In this example, all I'm saying is give me video. Just give me the default video, and then the success callback is passed a stream, which then you can do what you want with. Let's see that in action, in fact. So yeah, I'm going to a page that's calling get user media. Notice that I have to explicitly allow access to my camera there, and then bang, we're getting video from I've got a USB camera plugged in there, you can see. So hello everyone. What's nice about this, though, is when you see these, I don't know, these APIs coming up against each other. So in this example, we're getting video from the camera, and let me turn around this way and you can actually see something. What's happening is we're getting frame grabs from the camera, plumbing those into a canvas element, and then analyzing that canvas element pixel by pixel to give us ASCII art. Which is, it's just nice when these, these APIs can interact like this. Thinking about working with constraints, we can also use constraints to select the resolution of our camera. So, wow, that's slow. If we go to this web page, there we go. In fact, let's look at the source for this on GitHub, if that'll open. You'll see if you can see here, I'll just bump up the size a little bit. We've got 3 different constraints objects. These each represent kind of low, medium, and high res, so to speak. So when we click the button here, we're getting 640 by 360 right up to HD here, which is, oh, sorry, I've still got the other one open here. So let me just close that. And then, hang on, just pull that through again. So basically, we've got the ability to choose resolutions. There we go. You can see I'm getting the full HD from, hello. Wave to the camera. This is kind of crucial, of course, also when we're thinking about getting media from a mobile device and making sure that we're not overdoing it in terms of bandwidth. We can also use constraints to select camera sources. So let's do that now. I'm going to go for this on the device here. Let's show it on mobile device, I think. I can actually, if we look at, you can come over here, I can show it to you.
Okay, sure.
So basically, we can get the ID for the different devices attached to the machine, and then we can select different cameras depending on which we want. And as you can imagine, this is kind of bizarre. This is crucial again for devices that like phones and slates, where we obviously want to be able to do selfie mode or kind of crowd mode. So there we go. Yeah. Okay. That just about works.
I prefer selfie.
Selfie is good. And again, this is all done with constraints. Same with screen capture. We can do the same thing. So I'll just go out of full screen mode. So we've specified in the constraints that we actually want to get video from screen capture, which is slightly ridiculous because we're getting a screencast of a screencast. But anyway, you can imagine there are lots of kind of good use cases for that. People ask about recording. We have an API for this coming through, being specified and implemented, media stream recording for recording audio and video. There's also the media stream image capture API, which is kind of a taking photos API. You can do that with Get User Media and Canvas, but this gives us access, is proposed to give access to stuff like camera autofocus and zoom and so on. So I think that'll be great. Again, really good for mobile devices. So there's a lot about video.
Yeah.
I was wondering if Jan could tell us a little bit about the world of audio.
Yeah, what's video without audio? It's pretty much nothing, isn't it? So let's focus on audio a little bit. So we have a great thing that's been around for quite a while, the audio tag. Well supported, very easy to use, and it takes care of everything. Loads, decodes, buffers, and plays out your audio. And even includes a player. So you don't have to do anything more than that line, and you can play an audio file. That's great. But there are applications where that is just not enough. For example, precise timing is super important in gaming and being able to handle many different sounds at the same time, and music creation, etc. So we came up with the Web Audio API. And the Web Audio API is really just it's a pro audio environment in the browser, and it involves a lot of stuff. So let's start with just the look at what you can do for, as I said, you can timing, but you can also do cool things like create audio. So this here has built a synthesizer, and all this, the audio is created by Web Audio, and with all the controls, you can switch things on with perfect timing at any time you want. And some of the things, there you go. Rock away.
I'm not going to stay up here.
All right. So Web Audio can do that. So we just saw an example of creating audio. We can do timing. We can also analyze audio data. Super nice applications are, for example, visualizers and things. And even if you still want that long file that you want to download with audio tag, then you can just plumb that into Web Audio, and you get the ability to add visualizers, effects, etc. on top of that. So audio tag can can come as a way of loading audio into web audio. So I'm not going to go into all the details about web audio. It's just such a powerful tool. And what's really nice, all these things are implemented in native code in the browser. So you don't have to do this in JavaScript. In JavaScript, you have a nice node-based pipeline where you just plug in things and easily put it together. But it's really pro audio. So for example, a good example is that we can have input to output in 5 milliseconds. And I'll give an example of how that matters in a second. The support for web audio is also really great. It's really a pleasure to note that Firefox just 2 weeks ago released web audio on both desktop and Android. This means that we have web audio on Chrome, Safari, Firefox, on desktop, all desktop platforms, on Android and iOS. So. And Opera, sorry. Yeah, that's so new that it's not even in my mind. So, and it's not even on our slides. It's your fault. So. Okay. So one thing that's really, really exciting, and we started with this, that we have all these media APIs and that they work together, and we can do really, really cool things together. One example is how you hook up Get User Media that Sam talked about and showed video examples, but you can obviously use that to hook up your microphone and get an audio stream and do something with it. And a great thing you can do is you can plug it in as a source in web audio. So you get your microphone input, that's the source in web audio, then you can apply anything you want in web audio. For example, one great example would be you plug in your guitar, you plug it in here, and the audio that comes into web audio, you can apply filters and effects, and then you play it out 5 milliseconds later. So basically you have an effects box in your browser. But let's not only talk about this, let's show something and listen to something here. Many of you have probably seen this before. Chris here, he built a vocoder, which is a great instrument for I/O last year. And since then he, since then he has. So anyway, so since then he has added live input, as well as talked about Get User Media, but also now this works on mobile.
Can you hold the camera?
Let's see if we can get the camera.
Hello, Chrome Dev Summit.
Oops.
Oh.
Yep.
There we go. Hello, Chrome Dev Summit.
Live from the Nexus 5.
I did also want to say the synthesizer also works quite well even on iOS. There are a couple of issues I'm still working through with Firefox, but it really shows that these things work across mobile and desktop. It's not just on the desktop.
Cool. We are not in
You're
the right
still playing.
market. There we go.
Yeah.
Oh. Okay.
Stop that.
Next thing, when you have the audio in through Get User Media to web audio, then you want to plug it into peer connection, and then you can talk to someone on the other side through a WebRTC call and apply the effects. Next thing we want to do there is apply these effects on the output as well. That's in the works. So you can, for example, do spatialization on the output from a WebRTC call. Okay, Chris. Another great thing that we need for audio is being able to not only use the keyboard and stuff here, actually be able to connect MIDI devices like a synth, or let's look at...
You did notice before I was playing this keyboard that's connected through the WebMIDI API. But we also have a couple other apps that we've...
the audio?
Plug the audio back in. Knew we had something else coming. There we go.
Okay, dance.
I won't dance.
All right, they said they were going to dance. I just kind of looked, but
Okay, where's the music?
That was the
but
deal.
really, the key
He
here.
believed us.
Probably better they don't. The real key here, though, is that you really need, for a lot of audio applications, you need this very hands-on controller experience. And I can do things like shuttle through here and find a particular point and set a cue. That kind of stuff.
Hey!
There you go.
You got your dance.
Okay. We are quickly running out of time here, so let's skip to some other important things for the web and media on the web. One thing that we really think is super important for this to really work for the open web is open and free video codecs. So we have developed VP8, and that's been out for several years, that really address what you need today. But we didn't stop there. Now we also have VP9, which is the next generation that saves more bits at a really good quality. So you can look here at the bars in the middle. So we compare H.264 and VP9. And you can see the bar is the bit rate, how much we save all the time for the same quality. This was from Google I/O. So really a great job from our engineers to do this. And this is open and free and can be used by anyone at no cost. And the tools. Other important things for a full media experience is being able to, for example, do adaptive streaming. Your bandwidth is not always the same. You need to be able to handle changes in your bandwidth. And the media source extensions, one of the things they do is allow for that. We also have encrypted media extensions that make it possible to handle content protection. And I'm going to leave for you for things like... So we've got 1 minute.
Yeah, a few minutes left. I think we've got a little bit extra. We've got great support for audio and video and a range of platforms. Also thinking about like captions and subtitles and accessibility. And we've got great support for this as well. Just looking, I don't know if people have seen the track element. This is kind of a simple way of adding subtitles or captions to your applications. Chug, chug, chug. Okay. There we go.
The web is always changing.
Yeah, and you can see there that we've got track subtitles rendered over the video, and then I'm listing out for the queue change events, and then plonking that stuff in a div there. So just a really simple way to make your video more accessible and to add that stuff. The way you do it is that you add a track element as a child of the video element, and then you point that to a file that looks like this, which is just essentially some information about timing, and then the text of, in this case, the subtitles. There's also some information about the way the subtitles kind of hints about how they might be rendered there. This little link down the bottom here, actually, I think this is amazing. Now implemented in Chrome is the ability to do what's called in-band WebVT. This gives us the ability to bundle a track file with a video file in order to be able to distribute one file that contains the video and the whole thing in one package in one file. So we kind of run out of time here, but I'd just like to go just to one more demo that I think that really for me sums up how far we've come with audio and video on the web.
And here you'll get the real dance.
Yeah, this slightly weird video shows what we got here is 2 videos encoded with alpha transparency information, and these are just video elements. So that is weird. So we have the ability to do like CSS filters. These are just elements. We can double click on these, and I've got a little CSS animation. Double click the background. We have a video playing in the background, and actually, these are like basic sort of green screen videos, but actually the rendering is really stunning. So yeah, I'm just really pleased to see that stuff. So yeah, please, we really look forward to seeing what everyone makes of these APIs, because I think they are a great feat of engineering and incredibly powerful across platforms.
We only got to touch on a few things here, but there's much more. So
yeah. Okay. Thank you very much.